Hello, this is Sunday, it's August 8th, and we are headed into the final week of our online astronomy course. So this coming week, we'll be heading into Module 14. I'll be talking about what's in Module 14 here in just a second. But the week after that, not this coming week, but the week after that is the week of your final exam. Now, that's when your final exam's scheduled, but in fact, I know that at the end of the semester, it's a time when things get crowded, there's a lot to do, and so I've actually opened up the final exam and the constellation quiz and the signature assignment. So you can do those anytime starting tomorrow on Monday, August 9th. I've just sent out an email about that, and so there's details about theirs. There's a little bit more information about how the constellation quiz works, but please look for that. But you can take the final exam anytime starting tomorrow. That's Monday, August 9th, and you can have until the end of the day on Wednesday, August 18th to take final exam, constellation quiz, and the signature assignment. Please don't forget that signature assignment, because sometimes people do, and it counts half a letter grade. It only takes a very short time to do. You can do it in 15 minutes. And basically, all you have to do is write about a paragraph worth of stuff and just answer one question. And that's it. So that's what's going to be how the course is going to be ending here with the final exam, constellation quiz, and signature assignment. Now, Module 14, here we go. We're heading into that. And Module 14 is the study of cosmology. Cosmology is the study of the entire universe, how it came to be, what it's made of. And so that's what we're going to be looking at. You'll find out that the universe is about 13.8 billion years old. We know the age of the universe, and we know what the universe is made of too. And we know that by studying the pattern that you see behind me right here. This pattern that you see behind me is called the cosmic microwave background. So this was taken by a telescope that is sensitive to microwaves, and this is an afterglow of the Big Bang. The Big Bang is the expansion of space and time at the very beginning that produced the universe that we all live in today. And that Big Bang means that the universe started from a very hot, dense beginning when everything was together, everything was right next to everything else, and then everything just flew apart. And this, as you know from learning about the Hubble law last week, everything is moving away from everything else, and things twice as far away are moving away twice as fast. So in that hot, dense beginning, we can still see the afterglow of that hot, dense beginning. The radiation has cooled down now, 13.8 billion years later, to microwaves. And this that you see behind me is the pattern of those microwaves in the sky. This is a map of the entire sky. The midplane of the galaxy runs horizontally right through the middle of this. So right through the middle here, from here, and then going right over to the other side is the midplane of the galaxy. And this is what the sky looks like if you could see it in microwaves. Now, it's very, very uniform. It looks patchy here. I'll tell you why in a second, but it's very, very uniform. The sky glows. Remember that any object with a temperature above absolute zero gives off black body radiation. That goes for the whole universe. And the universe we know today is at a temperature of 2.725 degrees above absolute zero. 2.725 degrees Kelvin. And it's the same everywhere to within about a 100,000th of a degree. So there are little spots in the sky where it's a little bit warmer by a 100,000th of a degree than the average, and where it's a little bit cooler by about 1/100,000th of a degree than average. The warm places you see are in the yellowish colors, and the cooler places are in the bluish colors. And so that's what you're looking at, the places that were just a little bit warmer and a little bit cooler, and in the very beginnings of the universe. This is when the universe was about 300,000 years old or so. That's as far back as we can see. And why are these spots here? Well, the warmer and cooler spots shows you where there were concentrations of matter. And those concentrations of matter later became the patterns of the superclusters of galaxies that we see around us today. So that's what's going on, and you'll learn that the universe is not only expanding, not only is everything moving away from everything else, but the rate at which it's expanding is increasing. In other words, the acceleration of the universe says that the universe is going apart faster and faster and faster and faster. The expansion of the universe is accelerating. It's an amazing discovery, and that was made just by looking at the pattern that you see behind you, or you see behind me. Yep, the universe is expanding, going faster and faster and faster. And scientists describe that, astronomers describe that by saying that the universe is filled with dark energy. And let me tell you what dark energy is. First of all, it has nothing to do with dark matter. It's not dark. Dark matter is matter that just is non-luminous. It interacts with other matter only through its gravitational force. But dark energy is completely different. It's a repulsive force between any 2 points in space. So there's a little bit of space between my fingers. And so between those 2 points in space, the space is exerting a repulsive force. And if my fingers are twice as far apart, the force between them is twice as great. Now, on the scale of my, the distance between my fingers, this force is negligible. You don't even feel it. But on the scale of the separations of objects, like the separations of galaxies in space, that is where you feel the effect of this dark energy. And that is what causes the universe to expand faster and faster and faster. Now, I have to tell you, we don't know what dark energy is. Usually if we know that gravitational energy, for instance, comes from just every object that has mass attracts every other object that has mass. Or Einstein might explain that by objects moving through curved space and time. But we know where gravity energy comes from. We don't know what the source of dark energy is. It is the biggest mystery in all of science. So we're trying to figure it out, but so far we just don't know. But we do know a lot from studying this pattern that you see behind me. For instance, we know what the universe is made of. 68.5% of everything that there is dark energy. Another 26.6% is dark matter. About 4.4% is dead stars, cold gas, and the stuff that we're made of, our atoms. Another 0.5% is the shining stars and the glowing gas that we study in the night sky. So what a joke on astronomers this is. Astronomers have only been studying the pretty bits, the 1/2 of 1% that's shining and creates light. And finally, 0.005% is the energy of light, the energy of photons. And again, by studying the pattern here, we can tell the geometry of the universe. And what that means is, you might know if I have two parallel lines, if these are lasers, and I just shot out two lasers, and watch those laser beams shoot into space, those lines would always stay parallel. And that is an example of how flat space behaves. And we know that the universe is flat by looking at this pattern that you see behind me. And in fact, in your homework module, you'll see how that determination was made just by looking at how big these little blue and yellow spots are. So you'll find out that that means that the universe is going to expand forever. It's going to keep going until all the stars burn out, until we have a dead, very cold universe of black holes. And we'll also go the opposite way to the very beginning and find out what happened in the very early universe. And especially interesting is the first 3 minutes of the universe, because in the first 3 minutes, that is when the first atoms were made, where the first hydrogen, helium, and a couple other of the lightest elements were made at the first 3 minutes, at the 3-minute mark of the universe. And since then, you know where other elements have come from. Heavier elements are manufactured inside stars, and they're spread throughout the universe in a supernova or in novae. Other elements are made when neutron stars collide with each other. And so literally all the atoms in your body, all the atoms in this flesh, owe their existence to what you've been learning about this semester, because they were made by processes in the universe itself. Finally, to end it all, we'll just learn a little bit about the search for extraterrestrial intelligence, SETI. Is there life any place in the universe except on Earth? Well, right now, and you know because we've been talking about this semester, we are beginning a serious exploration of Mars, looking for past life on Mars. The little Perseverance rover is going around. It is just is about to start. If it hasn't started already, it's just about to start, drilling its first hole into the Martian crust. And it's at the bottom of it's at the lowest point of its landing spot. And that means it's gone as far back as possible. So these are going to be the oldest rocks it will be able to drill during this mission. So that's going to be happening in the weeks ahead. So you'll be learning about SETI, about the search for extraterrestrial intelligence. And finally, let me go to Stellarium. Let me go to Stellarium here and show you something cool that is going to be happening. And it's going to be happening this coming, it's the 10th, 11th, and 12th, or I'm sorry, the 11th, 12th, and 13th of this month. So it's like Wednesday, Thursday, and Friday. So let me bring up Stellarium here. There it is. And we are looking a little bit to the east of north when you see this. And there's some familiar things there, I hope you can see. Here is the big W in the sky. This is Cassiopeia. There's the constellation of Cassiopeia. Remember, these are the pointer stars. These 3 stars in Cassiopeia are pointers. You can follow them right over to this, which is the Andromeda galaxy. And this week is the Perseid meteor shower. This is one of the best meteor showers of the whole year. So if you want to see it, this is what it's going to look like on the 12th. This is on Thursday, August 12th. If you go out around 11 at night, go to a dark space and just look toward the northeast, and you will see meteors, the Perseid meteor shower. It's fun. Just go out there, take somebody with you, because it's more fun if two people are out there just looking at meteors, scanning the sky, and yeah, set up a chair and just sit back and watch. So I hope the smoke clears enough. The smoke has been terrible, but I hope you get a chance to see that. So this is the end of our semester. And remember, starting Monday, you can take the final constellation quiz, and you can do the your signature assignment. But I hope you've enjoyed this semester. I hope you enjoy learning about cosmology. And more than anything, I hope you go outside and every once in a while look up at the stars and just think about all the processes that cause those stars to form and live their lives and create the elements that make us up. So I've certainly enjoyed making these videos this semester. And as always, if you have any questions, just contact me, send me an email, do a Zoom meeting, meet in person, if you have any questions at all. But I've enjoyed talking to you. I hope you've enjoyed things, and I hope you go on, have very successful lives, and part of those lives involves looking up. So the last time I'll say bye-bye.